Hello, I'm Martin Sanchez, and this is the final project for microprocessors. So I'm gonna go ahead and start the program, and for that I need to turn on the switch. You can see that the program starts, and those are the last two digits of my C number, and you can notice that the LED is not turned on. Now it turns off, and the temperature calculations begin. And you can see the LED is turned on, and it gets brighter with the temperature. So I'm gonna try to increase the temperature by holding it, and you can see that the LED gets brighter and brighter. That is until it gets to 86, where it will reach its maximum of 95% of the duty cycle. You can see that at 87 it has the same brightness as it had at 86. See, it's the same brightness as in 87. But now at 84, the brightness starts to fall down. And when it gets to 76, it's gonna get a duty cycle of 10%, and from there downwards, it's gonna continue to decrease. And if the temperature were 0, first that would be very cold, but secondly the LED would be turned off. So the port 2 interrupt is set on P2.3. You can see this yellow cable, it goes there. It's going to get to the switch. To set it up, we got to initialize P2 dir to set it as an input, P2 ran for that bit to enable it, P2 out to that bit, P2 IE to enable the interrupt. We also got to initialize the P2 flag as cleared. And inside the interrupt routine, the microcontroller exits the low power mode, sets a flag to avoid any duty cycle to the LED, enables the 7-segment display, and finally clears the flag. Then the timer A0 is set by initializing the TACTL using the sub-main clock, dividing the frequency by 8, using up-down mode, and enabling the timer A interrupt. To get the right time of 1 second, it was necessary to set the TACCR0 to the corresponding value, which was calculated, but later adjusted after doing real-world testing, which was reasonable since there are many processes and other clocks involved in the program. So initially with the calculated value, it would take more than 1 second. This simple subroutine is used to get and calculate the temperature. The analog and digital conversion is set by initializing the ADC10 CTL0 to get the reference voltage from the CCC, setting the sample time, and turning the analog digital converter on. And the ADC10 CTL1 was set to P1.7 since it was the only port that was available from port 1, since the rest would go to the 7-segment display. And internal ADC clock was used, single channel conversion and single conversion. Then the ADC10AE0 was set to the corresponding bit to enable the conversion. This happens inside the timer A0 interrupt routine. So every second there's the temperature is calculated, and it's gotten by the temperature sensor and then calculated by the microprocessor. And lastly, the pulse width modulation signal is set by doing a timer A1 interrupt, contrary to the A0 that was used for each second routine. And the LED port was selected as the output by initializing P2 SEL to the LED speed, and then using the sub main clock and the count up. Then the duty cycle is set by TA1CCR1. On this subroutine, the system checks for the current flag so that the LED is not turned on at the beginning of the program. Checks what is the current temperature and calculates the duty cycle accordingly and proportionally to the temperature. So it seems that right now it's set at 80 degrees. And well, you can see that there's my name and C number, and I guess that's it for the final project.